All right, we're going to continue the topic of logarithms. We're going to do properties of logarithms. We'll start with change of base, and then we're going to talk about expanding and condensing expressions. All right, so change of base we'd really only use if we want to evaluate something in a calculator. This is just another way to write a logarithmic expression. So if you have log base a of x, you can rewrite them to have the same base, and it would just look like a quotient. We'd have log of our new base, b, right? This is our new base that wasn't originally there in our original expression. We have a new base, and whatever is of the function, whatever's the input of our function is going to go on top, and whatever our bases of the original is going to go on the bottom, right, with the new base. And then remember, this is the same as log base e, ln, right? So ln is log base e. So in this case, the only difference is that our base would be e, but no matter what, you get the same answer. Right, so if you have log base 3 of 23, right, your calculator really only has a log button and an ln button. Unless you have a graphing calculator that you have the option of putting in your own base. And maybe even in some scientifics, you are able to put in your own base, but it's a little bit of a hassle to do so. So what you could do instead is rewrite it using change of base formula. You can simply write log of 23 over log of 3, right? 23 was your original input and 3 was your original base. That's the same if you were to do ln of 23 over ln of 3, right? Because remember, ln is just log base e. As long as the two logs on the top and the bottom have the same base, then you'll get the same answer, right? So, and then I don't know if I mentioned it in the previous video, but if you just see a log, the log button on your calculator doesn't show a base. If you don't see a base, you assume it's 10, right? So this is the same as log base 10 of 23 over log base 10 of 3. All right, so these two examples, we see a log base 4 of 25 and a log base 2 of 12. If you were to try to put this in a calculator, you would probably have a hard time doing so, right? So to find the actual value of it, we can use change of base formula. Remember that this number on the inside is going to go on top, and then our base is going to go on the bottom, as long as we log both of them to have the same base, right? So this is the same as log of 25 over log of 4. Right, remember log, if you don't see a number there in the base, it's a log base 10. We call that a common log. And then this is the same also if you were to use ln of 25 over ln of 4, right? Because remember, that's log base e. Now, try putting this in your calculator. Use both the log button and the ln button. And make sure to close parentheses, right? So the input of your calculator might show up like ln of 25, right, with an open parentheses. Before you divide ln of 4, right, make sure you close that parentheses and then divide ln of 4, right? And then so try this and see what you get. And if you do this, you should get that this is approximately 3219, right, to 4 decimal places. On a test or a quiz, we wouldn't ask you to evaluate this without a calculator. So we'll either give you a little calculator portion that you're able to do this, or we'll just tell you to write the ratio, right? So this would be your answer, or this would be your answer, right? So hopefully you tried it out on a calculator. Any calculator for these examples is fine. If you tried log base 25 over log base 4, you would get the same answer, right? So try the same thing with number 2, right? This one, our input is going to be 12, so that's going to go on top. I'm going to write log of 12 over, and then our base is going to go on the bottom, log of 2, right? So these are equivalent, right? And if we give you this on a test or a quiz with no calculator, then I would just ask you for the ratio. Or you can also write ln of 12 over ln of 2, right? They mean the exact same thing, right? And if you put this in a calculator, right, you should get, let me see, you should get about, to 4 decimal places, 3.584 50, right? It was 496, right? But the 96 rounds up to 50, right? So you get something like that. All right, so we're going to get into properties of logs now. This is just a way to rewrite logarithmic expressions. If you see a product, right? So our product property is if I have log of something that's being multiplied, right? So this is u times v, right? U times v, right? Remember, multiplication goes hand in hand with addition. So if you see a multiplication on the inside of your logs, that is going to become a plus, right? Between two logs of these same numbers on the inside. So I'm going to have a log base u, or I'm sorry, a log base a of u plus a log base a of v. And this is the same as if I did log base a of u times v, right? And similarly, maybe we're given something that already looks like a sum, right? If it looks like a sum, then you know that you can condense it and go back to multiplication by writing it as a single log, right? So these kinds of problems will either tell you expand the expression, and if we're expanding the expression, then we want to make it as big as possible, right? We're trying to have as many logs in a single expression, right? And then you'll have problems that might say condense, right? And condense just means to smush it all together, write it as a single log. Sometimes we won't specify, but you'll know based on what we're giving you whether you need to expand or condense. All right, so similar with quotient, right? If multiplication goes with addition, then division is going to go with subtraction, right? This division, if I have log base a of u divided by v, this is going to go with subtraction, right? So similar, just like with the product property, it's going to write it as two log expressions subtracted by each other. And then if I want to condense it, right? So this was expanding. I want to condense it, and I see a subtraction. I know that I'm going to have to divide whatever's on the inside of my logs. All right. And then there's a power property, right? And the power property says that if I have log base a of something to some exponent, this exponent can be written as the coefficient in front of it, right? And then similarly, right, so this is expanding it. If I want to condense it and I see a coefficient in front of my log, then I would just bring this up to be the exponent, right? So it goes in either direction, right, depending on what the question's asking. What I would first say is if we're trying to expand, right, if I'm trying to expand, I would first do any addition and subtraction, and then take care of your coefficients, right? If I'm going to condense, I would first take care of any powers, right? So turn a coefficient into a power, and then I would multiply and divide. But of course, order of operations would still come into play. Like, let's say I have a coefficient in front, and the expression has a whole, like the entire expression has a parentheses around it, then you would have to do whatever's on the inside of that first before I do the coefficient, right? But just in general, if you just see multiple logs, this is how you would condense it, right? Do the powers first, and then any multiplication and division. And then if you're trying to expand it, then I would first do any addition and subtraction, and then turn the powers into coefficients, right? And then this probably is a little confusing at first, right? But we're going to try some more problems, and we're going to see how it works. Okay, so this first one on this page, we're just going to find the exact value. Same thing that we did in the previous lesson. It's pretty difficult to think of it in terms of logarithms, right? I know you guys are more used to writing it as exponents, so let's do that. Convert it to an exponential equation, and then we get 5 to the power of x is going to equal cube root of 5, right? And then cube root of 5, we can rewrite it as 5 to the 1/3, right? Remember that any root can be written as a fraction in the exponent. So we get 5 to the x equals 5 to the 1/3. And then using change of base, we can cancel out our bases, and so x equals 1/3. All right. And now these three examples right here, 4, 5, and 6, say to expand, right? Expand means to make bigger, right? I'm going to end up in all of these with a pretty big expression. right? So what you want to recognize in these is there any multiplication, division, or any exponents, right? And here we do have multiplication and we have an exponent, right? So I'll do it by color, right? So I'm going to say our multiplication, I'll do that in green, right? So 5 times x cubed times y. And then we also have an exponent, right? An exponent of 3, right? So remember, this multiplication is going to become addition, and then this 3 is going to become a coefficient, right? But like I said, if you're trying to expand, I would first do any addition and subtraction, right, before doing my coefficient, right, because you don't want to misplace it, right? So the first thing I'm going to do is turn all of my multiplication to addition, right, between logs. I have a log base 4 of 5 plus a log base 4 of x cubed plus a log base 4 of y, right? So these expressions are equivalent, right? All I did was I expanded it. So now we have multiple logs in one single problem. All right, and now this isn't fully expanded, right, because we have an exponent, right? If you have an exponent, you want to bring that to the front of your log and make that the coefficient, right? So we end up with a log base 4 of 5 plus this 3 in the exponent is going to become the coefficient, so I get 3 log base 4 of x, and then everything else stays the same, right? Plus log base 4 of y. And now if you look at all of these log expressions, right, or log terms, you don't see any more multiplication, I don't see any division, and I don't see any exponents to be rewritten, right? So this would be my final answer as an expanded expression. All right, so that's what we mean when we say expand, right? Make sure there's no multiplication, division, or exponents on the inside of your logs. All right, if you look at the next one, ln, remember ln is just log base e, right? So just treat it like you would any other log. And let's identify what we have. Do we have any multiplication, division, or exponents? We have a division, right? So this is going to turn into a subtraction. And then we also have a square root, right? Square roots, remember, can be rewritten as exponents, right? So this cube root right here, this can be written as a 1/2 exponent, and then this is going to become a coefficient. All right, but like I said, I'm going to do any addition and subtraction first. Right, so in this log or ln expression, what is being divided? It's the square root of 3x minus 5 and 7, right, is being divided. So I'm going to have ln of the cube root of, square root of 3x minus 5 minus ln of 7. All right, so that takes care of our division, and now I want to take care of this square root, right? Remember, square roots can be rewritten as an exponent of a half, right? So I'm going to have ln of 3x minus 5 to the 1/2 minus ln of 7, right? So I didn't expand anything there, I just rewrote it. But to expand it, right, we notice that there's a 1/2 in the exponent. I would put this in front of my ln. So this is going to equal 1/2 ln of 3x minus 5 minus ln of 7. And I'll look in each of your ln expressions, and you don't see any more multiplication. We don't see any more division or exponents. So some of you might look at this and say, well, there's a multiplication right here in this 3x, right? Why don't we make that ln of 3 times ln of x? Because this whole thing is a term on the inside of my ln expression, right? So I have 3x, but it's not just a 3x, it's a 3x minus 5, right? So you can't make this into ln of 3x minus ln of 5. I know a lot of you are tempted to do that. There's a lot of room for error here, right? It's not particularly challenging, but you need to be careful with how you write these, right? Because this is not something that you can expand. You can't expand 3x. right, within this expression, right? So you would just leave it like this, and that's all you have to do. All right. So this next one, let's do the same thing, right? So I see over here a division. This is going to become a subtraction. On the top, I see a 4x squared. This 4x squared is 4 times x squared, and this right here is going to become a plus. And then both on the top and the bottom, I have an exponent, which is going to become a coefficient. And then I have a square root, which I can rewrite as 1/2, which is also a coefficient. But again, I would do any addition and subtraction first. Right, so I would turn this into log base 3 of 4x squared minus log base 3. I'm going to go ahead and rewrite that square root as to the power of 1/2. Right, so I did this first, just the division. And then now let's do our addition, right? So remember, this is 4 times x squared. So this is going to become log base 3 of 4 plus log base 3 of x squared minus log base 3 of y to the 1/2. And if you want to be extra specific and say that this whole thing was in the top, right? This whole thing is what's being divided with the y to the 1/2, right? So you can put it in parentheses. All right, just to emphasize that this whole expression represents this part of your log originally. All right, and now let's take care of any exponents that we see, right? We see an x squared, that's going to become a coefficient. We see a 1/2, that's also going to become a coefficient. So I would write this as log base 3 of 4 plus 2 log base 3 of x minus 1/2 log base 3 of y. All right, and then look at each of our logs. I don't see any more exponents. I don't see any more multiplication or division. So this is your entire expanded expression, right? So you're making this small expression into a much bigger one. All right, now these problems say to condense, right? So like I said with condensing, you want to take care of any coefficients, turn them into powers first, and then take care of any addition and subtraction, right? So unless, of course, I mean, if you look at 9 and 10, you see that you have some brackets around the entire expression, then you would, of course, do whatever's inside of your brackets and then take care of whatever's left on the outside, right? But just in general, right, why don't we take a look at this one right here? We have coefficients. I have a 1/2 and a 3 in front of the log. And then in between the two, I have an addition, right? This is going to become a multiplication. All right, so first, I'm going to take care of my coefficients, turn them into exponents, right? And it's going to become the exponent of whatever's on the inside of your log, right? Not of the entire thing. All right, so we're going to have a log of x to the 1/2 plus log of x plus 1 to the power of 3. Right, so just be careful here. You don't want to put this whole thing in parentheses, right? It's not the whole thing to the 1/2, and it's not the whole thing to the third power, right? It is just whatever's on the inside of your log, not the whole thing, right? So let me erase that for you guys. All right, and then after you do your exponents, you can now take care of that plus in the middle, right? This plus is going to be a multiplication. I'm going to multiply whatever's on the inside of my logs. Also make sure to turn this 1/2 into a square root, right? Remember, anything to the 1/2 is the same as a square root. So this is going to equal log of the square root of x times x plus 1 to the third power. All right. And then this is all you would do. You only have one log now. This is fully condensed, right? Only one log. You don't have any coefficients, so you can leave it like this. All right, so that's the process for condensing, right? We're going to do the same thing with the next one. Notice, do we have any coefficients? We do, right? We have a 2 in front of this ln. I know that that's going to become an exponent. And then between the two, I have a minus that's going to become a division. All right, so let's first take care of our exponent. It's going to be ln of x plus 2 squared minus ln of x. All right, and then that subtraction, we can treat it as a division, right? So this is going to become ln of x plus 2 squared divided by x. And then this is fully condensed, right? We don't see any coefficients. We don't see any extra logs. We see a plus, but that's on the inside of a log already, right? So we don't need to do anything with that, right? If you write it as a singular log, that's all you need to do to condense. All right, let's do the same thing with the next one, right? This time we have a 1/3, that's our coefficient, but this is the coefficient of the entire thing. The entire thing is in brackets, right? So I would first do whatever's on the inside. Notice that on the inside of your brackets, right, you only have a plus, right? That's the only thing that you're trying to take care of now, and this is going to become a multiplication. And then this 1/3 is going to end up being an exponent, right? But of course, let's do the inside of this first. We get a log base 2 of x times x plus 1, all right? And then all of this is to the 1/3, right? So this 1/3 is going to become the exponent of whatever's on the inside, right? Don't make that mistake. It's not the entire thing that is to the 1/3. It's just whatever's on the inside. And then this is going to become log base 2 of x times x plus 1 to the 1/3. And then 1/3 we can rewrite as the cube root, right? So don't forget that step as well, right? 1/3 is the same as cube root of x times x plus 1, right? And then this is fully condensed, right? No more coefficients, no more plus and minuses between our logs, right? There's only one log, all right? Try the same thing with the last one, right? We have on the inside, we have a subtraction, that's going to be a division, and we also have a coefficient, right? And this coefficient of 2 is going to become the exponent of this expression right here. And then on the outside of the whole thing, I have a 2, which is going to become the exponent of the entire thing, right? So let's work on the inside first, right? So on the inside, I would take care of that exponent first, of that coefficient of 2. So we're going to get a log of x plus 3 minus log of x minus 2 squared. And then this whole thing has a 2 in front of it. And then take care of this subtraction, right? That subtraction is going to be a division. So we're going to have a log of x plus 3 divided by x minus 2 squared. All right, and then don't forget again, this whole thing has a 2 in front of it. And then this 2 is going to become the coefficient of the entire thing. And then this is going to become a log of x plus 3 over x minus 2 squared. And then this whole thing is squared. All right, and then so this is our condensed expression, right? I don't see any more plus and minuses between logs, and I don't see any more coefficients. And then this is the fully condensed expression, right? So it takes a little bit of work, takes a little bit of thinking. It's not as straightforward as some of the one-to-one expressions or equations that we've had, or like solving equations, right? This one you actually have to think a little bit harder, just to make sure that everything does what it's supposed to, right? That's really how you can check your work, is that make sure that every little operation does exactly what you expect it to.